morning, fellow Earthlings, and everyone else too. Welcome to day 3 of the Pihut's Maker Advent Calendar 12 Projects of Codemas. Let's get right on into it. Alright, time to unbox day 3. Alright, let's see what we got. Looks like we've got some more jumper wires. A mini breadboard. And 3 tall tactile buttons with button caps. Alright, let's get started. So, Maker Advent Calendar day number 3, bashing buttons. Welcome to day 3 of your 12 Projects of Codemas Advent Calendar. Today we'll be adding physical inputs to your program using buttons. So far we've relied purely on code to tell our components and program what to do and when. Now we're going to use physical buttons to do that, which will act as triggers in our program to determine what happens. Let's go. Alright, so we saw during the unboxing that we got a mini breadboard, 3 tall tactile buttons, 3 button caps, and 7 meld-to-meld jumper wires. Today's project. Today we'll be programming the buttons in your box as inputs for our code. While we can easily use code to trigger our program to do things such as counting, components like buttons and switches allow us to physically interact with our project. Most buttons are very simple, just connecting a circuit together which then sends a signal to our Raspberry Pi Pico over our chosen GPIO pin. You could do the same by simply touching 2 wires together, but of course buttons make this far more convenient and user-friendly. We're also going to be using the mini breadboard as our little control panel for our project, as we're going to make use of our LED circuit from yesterday. It's a handy part to have in your growing stash of bits, and it'll come in handy for some other boxes too. For some of our other boxes too. Oh, and the button caps, they're just a nice little extra that make each click a little bit more satisfying. Construct the circuit. As always, first make sure your Pico is disconnected from your computer. Now grab the mini breadboard and pop each button into a few holes apart, making sure the legs sit either side of the little channel in the middle. All right. Alright, like our larger breadboard, that central channel disconnects one side from the other, which is handy when wiring projects. Otherwise, all of our button legs would be connected together, and we really don't want any magic blue smoke. Now we need to connect a 3.3 volt pin from the Pico to the top red lane on our main breadboard. Pop a jumper wire into the 3v3 out pin on the Pico, physical pin 36, and then connect the other side to the top red lane. You then need to connect the red 3.3 volt lane to one side of each of the buttons. Go for the right side like we have below. Alright. Okay, so physical pin 36. Alright, so that connects physical pin 36 to the outside here, and then see, connect the 3.3 pin. Alright, I think that should be good. Lastly, we need to connect the other side of the buttons to GPIO pins. Add a jumper wire into GPIO 13, 8, and 3. Important, the GPIO pin must be on the opposite side of the button, as the left and right side are disconnected until you click the button. If you had the GPIO and 3.3 volt wires on one side, the button would act as if it was constantly clicked. Alright, I think that should be good. I guess we'll find out. Activity 1, button test program. We'll first run a simple test program on one of the buttons. Each button has been wired to a GPIO pin, so we can set these as inputs to trigger some text to print when they're pressed. We'll use a while loop, which we learned about yesterday, so that the program keeps watching for the button press forever, with a new function, an if statement, to determine what happens when the button is pressed. If statements. If you've used Microsoft Excel or similar software previously, you'll have already guessed what if statements do. If statements allow us to give our code different outcomes depending on values, inputs, and many other things, such as if the first button is pressed, light the red LED. If the condition for the statement is met, our program will run the code inside that code block, which is indented underneath. Indentation is important again here. The while loop block is indented, but as the while loop contains an if statement, we indent yet again for the if statement block of code. Look at the example below to see this in action. If statements can be very powerful, and there are lots of different and advanced ways to use them. You'll use them lots when making your own code. We'll start with a nice simple example, but first let's explain something else in our on-code pull downs. Our code below also uses pull downs. You can see this at the end of each button set up sections as pin.pulldown. So why do we add this? When we use a button, we're sending 3.3 volts to the GPIO pin to set it high. However, we need to make sure the pin is low in the first place, or our code might not be able to detect the change, and or it might trigger itself randomly. This is because GPIO pins with no pull down or pull up can be floating between 0 volts and 3.3 volts. Pulling down the pin to 0 volts ensures it's always low to start with. Sometimes this is achieved by using physical resistors in a circuit. However, some microcontrollers, such as our Pico, have this functionality built in, and we can simply enable them in our code. The code. This initial simple code uses just the first button. The code includes our usual imports and pin setup, then starts a while loop. The while loop contains an if statement that looks for a high signal, or 1, on GPIO 13. If the button is pressed and the signal is sent to that pin, our code will print button 1 pressed. We include a short delay in this loop to give our finger a chance to release the button to avoid the code triggering many times from a single press, known as debouncing. Values of 0.1 or 0.2 seconds usually work well. Copy the example over to Thani and give it a go. Copy that and plug in the Pico. Alright, so button 1 pressed. That's good news. Alright. Activity 2, multiple button inputs. Let's add our other buttons into the code and change our if statement to make it watch for any of them being pressed. To do this, we add setup lines for the other buttons, then add additional if statements below the original one. Our code will simply check each condition in order. If one of the conditions is met, if a button is pressed, it will run the code for that button and then continue to check the remaining statements. And it will do this forever because we have this in a while true loop. All right. 2 pressed, button 3 pressed, button 1. So looks like we got them all right. Activity 3, multiple button inputs with elif and else. What if we wanted to do something more advanced with our buttons? Maybe we want to ignore buttons 2 and 3 if button 1 is being pressed. Do we want something else to happen if none of the other buttons are pressed? Perhaps we want something to happen if we hold 2 buttons down at the same time. We can do many of these things and more by using our if statement with additional statements elif and else. Let's explain how they work before we try them. The elif statement. The elif statement is short for else if. If your first if statement isn't true, your code will then check each elif statement in order to see if any of those are true. If none of the elif statements triggers, it will run the code block for that statement only and then stop checking the others in the loop, unlike regular if statements which keep checking each one after the other regardless of what happens. In the example below, we use if, then elif to tell our code to check if button 1 is being pressed, and if not, check button 2, and if button 2 isn't being pressed, check button 3. Tip, there should always be an initial if statement first. Alright, so let's copy this over. If 1 is being pressed, and if not, all right. The else statement. The else statement says if none of the statements above have their conditions met, do this instead. It can be useful if you want something to always happen when none of the above elif statements are being met. Here's a short example using just 2 buttons. You can try where we always print no button presses if none of the buttons are being pressed. The commentary shows you where the else statement is being used. Okay, so it's just using the first 2 buttons. All right. The code. Now that we know what elif and else do, let's put them to work while adding our LEDs back into our program. The code below first checks if we've held buttons 1 and 2 together. It does this by using an if statement with an and between 2 conditions, asking for both of these to be met at the same time. If the buttons are both held down, the green LED will light. We then use an elif statement to check if button 1 is being pressed on its own. If so, the amber LED will light. Then we use an else statement to light the red LED and turn all the others off if nothing is being pressed. Button 3 isn't being used for this example. All of this is in a while loop to make it run forever. Alright, so hopefully you can see that. Let's turn these lights off. Alright, so if nothing is being pressed, then the red LED will stay on. If button 1 is being pressed on its own, the amber LED will light. And if 1 and 2 are done together, then the green LED. Alright, so red with nothing, amber with just button 1, and then button 1 and button 2 do green. Alright, activity 4. This button or that button. Another trick we can use with buttons and if statements is to use or between conditions to check if one of our buttons is being pressed, but make them all trigger with the same result. We added an example below which looks for either button 1 or 2 being pressed. Once you've tried it, why not have a go at adding button 3 back into the code and then make all 3 buttons trigger the LED? Hint, just add another OR to the same line in the same way. Alright, so let's see what's happening. If button 1 or button 2, print button 1 or 2 is being pressed and then turn the green light on. Alright. Add button 3 back into the, alright. So we can just add another oh, button 3 is not defined. Okay, so that was button 3 was pin what? 3. (13, 8, and 3). Button 3 is pin 3. Alright. So now 1 lights it, 2 lights it, or 3 lights it. Alright, sweet, that worked. Activity 4, this button or that button. Or wait, that's what we just did. Activity 5, toggling with buttons. Another handy feature we can use with GPIO pins is toggle. As you might have guessed, this toggles a pin status from high to low to high and so on. The example below is mostly the same but uses button 1 to toggle the red LED on and off. Once you've tried the code below, why not try adding the other buttons and LEDs back in, toggling each of them. Alright, let's give it a try. This button 1. So we press it, turns off, press it, turns it on. Let's try adding the other buttons in there. Got to get the copy and paste action in. Nope. Okay, while true, time sleep. If button 1 is on, print button 1 is pressed, red dot toggle. Toggle the red on and off. So you can all right. Button 1 is pressed, we're turning the red on and off. Button 2 is turning the amber on and off, and then button 3, and we can turn them all on also. Oh. Alright, there we go. Day 3 complete. Great job, makers. You've now got the skills to use physical inputs with MicroPython, which will come in handy for the rest of the calendar, and can code if statements in all sorts of interesting new ways. Today you have learned how to create a circuit with physical inputs, how to code physical inputs with MicroPython, what if statements are and how to use them, how to use elif and else within if statements, how to use and or within if statement conditions, and combined physical inputs with physical outputs. As always, please do not disassemble the circuit until tomorrow, where we will explore the next fun component. See you then. As always, thanks for stopping by. Hopefully that wasn't too rough to watch. I'm going into these completely blind and just doing it one take and seeing if I can figure it out on the spot. And I'm definitely not an experienced with any of this, so let me know if you like me doing it like that or not, but see you tomorrow.